Okay, so capital allocation line. So capital allocation problems are set up where you have a risky portfolio and a risk-free asset. So in this case, Fred can have a invest in a risky portfolio with a 25% standard deviation and an expected return of 15%, and T-bills which currently pay 4.5%. Standard deviation of T-bills is 0. So how much should Fred put into each investment if he wants to earn 12%? He what he needs to do is set 12 equal to the return on the risky portfolio, 15, multiplied by the weight that he wants to put in the risky portfolio, plus the return on the T-bill, 4.5%, multiplied by 1 minus the weight in the risky portfolio. This 1 minus, that gives us 1 minus the weight in the risky portfolio, gives us the weight in T-bills. We can solve, now we can solve for WR. So to do that, so we multiply this out and we get 15 WR minus 4.5 WR is equal to 12 minus 4.5. So the 15 just comes from here. The minus 4.5 WR is 4.5 multiplied by the negative WR. The minus over here, the 4.5 is just this 4.5 divided by 1, so we subtract it from both sides of the equation. So this gives us 10.5 WR is equal to 7.5. So WR, or the weight in the risky portfolio, is 7.5 divided by 10.5, which is 0.7143. So the weight in T-bills, WT, is just 1 minus 0.7143, just like up here, which is 0.2857. So we can draw this the capital allocation line here. So we've got expected return, and go down here and across, and we'll have standard deviation. So we've got our risk-free rate, 4.5 and 12, and then we've got 15. And we know that the standard deviation on this the risky portfolio is 25. So draw a line out here. So this is our capital allocation line. Probably more appropriate to put a dashed line. So we don't know what this number is, but we can calculate it. We'll calculate it on the next page, but we've just graphed our capital allocation line. So we need the standard deviation on this portfolio. So standard deviation on the portfolio is the standard deviation of the risky portfolio, 25 times its weight, 0.7143. So that is 17.86%. And then we can calculate the Sharpe ratio now. So the Sharpe ratio is expected return on the portfolio, 12 minus 4.5, divided by the standard deviation, 17.86. And that number, I believe it's 0.42. Let me double check. Yes, 0.42. Right, I can go back to the next page now. So this number, complete my graph. So the yeah, one thing to note about every portfolio along this capital allocation line is going to have an identical Sharpe ratio. So they something. You know. So also anything beyond this point. Anything beyond this point with this the optimal portfolio is represents would be investing at a margin. So you would be, in addition to your own funds, you would be borrowing. So that's how you would obtain rates of return beyond the 15%. But you would also increase your risk. So your standard deviation is going to go up as well.